So I'm going to talk, and I think we'll manage without the slides. Look, this continent, to start at a high level, Europe, with the exception of European Russia, is the only continent with a commitment to complete decarbonization. And it's set apart in terms of policies, practices, demand for technologies by that commitment. As a consequence of that commitment, as everyone in this room is aware, I'm sure, we have a target for the EU to generate 20% of its energy from renewable sources by 2020, and that target translates for the UK into a target for 15% of our energy in all forms, electricity, heat, and transport, from renewables by 2020. I spend quite a lot of my time every week trying to figure out how we're going to do this, how much progress we are making, how much is it costing, perhaps most important, what are the barriers to getting there faster and with a higher degree of certainty. So, first of all, I want to start with two comments, very short comments. It is true, and I think there was a Siemens slide that showed this morning, that we are near the bottom of the EU league table in terms of where we are today, but we are adding new capacity and making new investment at a rate that is consistent with making the target in 2020. We are on track with our plan, which we have published and sent to the EU to get to that target. The second comment follows from the first. We believe that the target is achievable. There are many people who doubt that, but I will try to convince you that the target is achievable. Now today, 15% translates into a target of 234 terawatt hours each year, total energy from renewable sources. This number is derived from predictions of demand for heat, electricity, and transport. Now, our projections of demand are not all that good, and not all that perfect. They were given quite a bit of a shake-up by the economic events of the last few years, and we still don't know whether the demand trajectory that we are on today is one that is a new trajectory after 2008-9, or we are going to return to the old trajectory. And I think that's something which introduces quite a degree of uncertainty into this. Right now, our projections for 2020 are that demand for electricity and energy for transport will be relatively flat, and that demand for heat will decline substantially over the decade. If we had seen the slides, I had some numbers for that. The electricity one is a bit complicated because we get to flat by some things by driving efficiency in some areas, but also having new demands for electricity, as several people have talked to. We have to remember that while the total terawatt hours are crucial to our target, and that's the only thing that is important when we're driving towards fulfilling that target, as was shown a couple of talks ago, the balance between peak and off-peak is crucial to how economic it is for us to achieve that target. So today I want to talk in the next few minutes about, in getting there, what matters. What actually matters. And I think, broadly speaking, there are 5 things, and if I talk about these 5, there will be 3 people when we sit down for the panel who will say, but you didn't talk about 6, 7, and 8, I'm sure. Okay, number 1, it's important to concentrate on the big things. In DEC, we have done some work which will be published in a few weeks' time, where we looked at 22 technologies that could contribute to achieving the target between now and 2020. We've worked with the industry's broad set of players that supply these technologies or are committed to implementing them. Clearly, it's a different thing if you're dealing with offshore wind. We look at big developers, big suppliers of turbines and so on. And we get everything from the whole supply chain through to implementation and making commitments to, is this me? Probably. You get right through the whole thing up to how many gigawatts are going to be deployed by talking to a few people. It's rather different when you're talking about heat pumps. The number of decisions that have to be made are very different across the different sectors and the different technologies. All the numbers that we come up with are not our numbers. They come from the players in the field. I want to stress that because in the past, DEC has published sort of a renewable energy strategy and scenarios which I would say are a reasonable person looking at this might believe that this could happen. But now we are doing a bottom-up analysis of this, asking lots of people, how much can you do? Give us your central case. Give it to us in 2-year increments so we have an idea of what the trajectory looks like over the decade. And also give us a high and low case and tell us what drives you to what would drive you to the low case or the high case. Sometimes you get to the low case, the difference between the two just because of uncertainty. Like we think our company could supply 100,000 plus or minus 15,000 heat pumps. Sometimes, and more interesting, I think, or at least as interesting, people say, look, there are these 3 barriers. And if you remove them, we can go way beyond our central case. But if you don't, we're never going to even make that. And we have spent quite a lot of time, especially after getting all of this input, in a number of workshops with industry participants on trying to understand the barriers. One of the things that Chris Yoon said when he became Secretary of State is, I want to see for renewables all the barriers up on a wall, and then let's have a systematic approach to taking them down. And that's a big part of what we are trying to do. We are not going to be able to show, the solution to everything, but we are at least going to say, this is our understanding of what we have to do. If we take a journey for an onshore wind developer, an offshore wind developer, whatever, from start of conception of a project till they're generating, where are the red spots? Where are the constraints? And try to deal with those. When we look at this central case and add it all up, it comes out for all the technology, for all the 22 technologies, it comes out to 248 terawatt hours. That's not fixed, that's just what came out of the process. So a little bit more than the 15% target, but with a pretty big range between the high and the low. Second, we have a small base of about 10 terawatt hours from hydro and landfill gas that exists today and not expected to change very much over the decade. When we add to that base 7 of the 22 technologies, we get to greater than 90% of the target. So in talking about what matters, there are only really 7 things out of the 22 that are important to focus on. What are the 7? They are on and offshore wind for 2, ground source and air source heat pumps for 4, biomass electricity, biomass boilers for heat, and biofuels broadly defined for transport. first and second generation biofuels in all forms of transport. Nothing else is material in this decade. Now, there's plenty of upside, by the way, on these 7 technologies to more than make up for the missing 10%. Now, some of the big things are likely to be big in this decade and beyond. If we look at offshore wind, our trajectory I'm going to turn this off. I'm sorry. I really, if this is it. Usually you blame Bill Gates for problems, but here we blame Steve Jobs for the problem. Okay. Some of the things are going to be big in this decade and beyond. If we look at offshore wind, our trajectory is that as we go into the second half of the decade, we are still increasing the amount that we deploy. If we look at onshore wind, it will be a big generating factor for the UK beyond this decade, but we will not be deploying at a very great rate beyond the end of the decade. We will have used up most of the good sites. If we look at some of the biomass things are a little trickier. So our belief is that biomass electricity could play a very big role over the coming decade, but that some of that, at least, will be past, and it may decline beyond 2020. It helps us to meet our target. It's a good thing to do, but it may decline afterwards as other things come in. For example, we have coal-fired power stations which are coming to end of life, and the length of time when they can operate can be extended by running them on biomass instead of running them on coal, but not extended for very long. So we will get a gigawatt out of the conversion of Tilbury Power Station by RWE to biomass, which they've already announced, but we won't have that beyond 2020. That's fine. As I said, I'm focused on this 2020 target, and there are other things that will be important afterwards. How certain are we of our projections? I think while there's a big uncertainty and big spread between low, central, and high cases, I think the numbers are pretty good. And for the small things, it doesn't really matter. There are some of the small technologies where we project 1 terawatt hour. It doesn't matter if the answer is 3. We could be off by a factor of 3, it still doesn't matter. The one place of all the things which get counted, you would say it's not a renewable technology, but it gets counted, where there's big uncertainty is electric vehicles. Because if we look at the projections from the Department for Transport, they are still very low. And there, instead of being off by a factor of 3, we could be off by a factor of 10 to the 5th. And that does make a big difference. And it makes a big difference to the balance of how we get to our transport target between bio-based solutions and electrification solutions. So the first big point I wanted to make, and I'll make the others faster, is that from a policy perspective, we only worry about the big things, these 7 big technologies. We're going to get the policies, the incentives, the removal of financial and non-financial barriers right for these, and if we do that, we'll make the target. And we can caveat that a little bit by saying that we will devote some of our innovation spending to things that may be small by 2020, but could be big both in terms of their ability to contribute and in economic development terms for the UK in the decade after that. Okay, number two, demand or efficiency really matters. What we do know is that there are many things we can do to reduce demand, and as has already been said, they're pretty much the cheapest things that we can do. So many of the technology initiatives discussed here today enable this demand reduction and management to happen. My friend David Fisk used to say that only 25% of our energy today is actually managed, unless you count parents walking through the house turning off lights as energy management. So there's a huge opportunity. Some of this is being grasped, particularly for commercial buildings, supermarkets, department stores. There's still a long way to go. I think smart businesses realize the importance of energy management. By cutting out energy waste, they lower their prices, and hopefully, when they're smart about it, in the process, they capture some of the additional disposable income from their customers. The prototype for this, the absolute role model, is Walmart, Asda here in the UK. They're very canny about this. You talk to Walmart people, I've been to their meetings, where they say, look, our customers are poor people. Every cent that goes into poor refrigeration, wasteful energy from refrigeration in our stores, that's money that they don't have to spend on other things. So we save on refrigeration, they buy something else in the store. The government is establishing, here in the UK, establishing an Office of Energy Efficiency. And the Green Deal program is a major effort to improve energy efficiency, especially around heat. We will want to link renewable heat incentive programs for domestic dwellings with the Green Deal. You might think this is just a yawn, who cares? I don't agree, actually. I think it's really important. I see a major change happening in the government, especially in the last year, in the attitude towards efficiency. A real belief in its ability to deliver material reductions, and that was not there before. Smart homes, smart meters, smart grid are crucial to enabling this to happen, and so is the Green Deal. Okay, number three, cost is important. If we take the 7 technologies that I mentioned and stack them up in order of increasing cost, offshore wind is today the most expensive. And if we project through ahead on cost to 2020, a very uncertain thing to do, offshore wind is still the most expensive. The heat things are the least expensive. The projection for 2020 is that many of the renewable heat things that I mentioned come down to be close to parity with other ways of doing heat. There's a limit to how much we should expect our customers to pay, and it's incumbent upon the industry, for all of the technologies and for all the players, to drive down costs over the decade. We cannot and we will not be subsidizing new generation in 2020 at the same rate that we're doing it today. We just can't do that. We should just find a different approach if that's what the answer is. The subsidy program, the incentive programs, are designed to reward those who deploy early, give them a guaranteed return on their investment, and not over-reward those who hold back. Costs must come down. For offshore wind, they have to come down by more than 30% over the decade. And the industry, I think, is committing to a greater than 30% reduction. It's unacceptable where there are companies in the supply chain who have a dominant position for them to use that dominant position to increase their margin as costs come down in other parts of the supply chain. Everyone has to be on the team for cost reduction or we're not going to make it. Okay, point 4. Finance matters, clearly. Genevieve showed some numbers on that. We probably need, for the renewables, at least £100 billion in this decade, just for the renewables program, over and above the government subsidy. The balance sheets of the big players currently in the mix are not strong enough to support this. That's clear. It's a joint role, I think, of government and the private sector to bring new players into the UK market and to be sure that we attract a good share of the investment from the existing players, from the multinational existing players. The finance group of the Offshore Wind Developers Forum, which I co-chair, among other things, and the finance group of the REA and others are working this problem very hard. A combination of developers, banks, legal, interesting people with innovative legal ideas from Linklaters and so on are working there. We're very far from there, but I think we're making progress. At the moment, we do hit finance constraints for some projects, but usually, one way or another, we get past them. There's clearly a reluctance, particularly in offshore wind, to finance construction costs and construction risk. We believe that operating assets will be saleable, the process known as recycling, and that once we're started and have assets going, the demand for capital, while still be great, the gap will be smaller. But right now we need to find ways of dealing with risk mitigation, and I think the Green Investment Bank has to have this as one of its key roles. So clearly finding financial wherewithal is critical. Okay, for number 5. Did I say there were 5 things? Yeah, number 5. For electricity, grid matters. We need to build out the grid. We need to make it fit for purpose for the 21st century. It has to be fit for purpose for the mix of generation that we're going to have in the 21st century, which will include substantial variable generating capacity. We need to be sure the commercial arrangements for those building and operating new grid assets are both consistent with our approach, and our approach is that generation and transmission are separately owned, always. And then they have to be commercially robust. And we need to take some strategic decisions about grid. And we're doing those, in particular around what is called coordination. And I won't explain it. It's a code word that means an approach of whether for each offshore wind farm, to put it in a general way, for each offshore wind farm there is a grid connection to shore, or there is some coordinated approach to connecting up offshore wind farms to the grid. This is a big deal. It's not only in the generating technologies that technical advance is taking place. There are new ways and new technologies, everything from cables to software and a lot of stuff in between, hardware and management, where advances are taking place for the grid. Our decisions need to at least recognize and in some cases anticipate these changes. So these are the 5 things that I wanted to stress today that I think matter. I think they matter to a lot of the specific things that people in this room are working on. 7 big technologies: demand, cost, finance, and grid. If we keep our focus on these things and work systematically to remove barriers, we can win, and we will win. Thank you.